Welcome to Sundar's lecture. This is lecture number 21. And what are the topics we have seen in the last lecture? See, in the last lecture, we have started a different topic, right? A new topic, circuits with the dependent sources. And we have discussed what is dependent sources. That means current dependent voltage sources. There are two sources, voltage sources and current sources. In voltage sources, there will be sources that depends on current. So, those sources are called as current dependent voltage sources, and the voltage source which depends on some other voltage in the circuit. That sources are called as voltage dependent voltage sources. And also the same thing that we have seen in the current sources, right? Current dependent current sources and voltage dependent current sources. Those two topics we have discussed in the dependent sources. And what we have done, we have taken an example problem. See, this is the problem we have taken in the last class, and we have tried to solve this problem, right? So what we have done, we would have found what is the voltage. That means the current I1 we have found, and we have substituted in this voltage source, and we have got that 2.886 volt as the final answer. Now we will further move with a complicated problem. Since then we can easily understand the dependent sources problem as well as applying KCL and KVL in the problems, right? So little bit complicated problems we will take so that we can easily understand. See, this is the problem given. So what they are asking you to find, they are asking you to find VAB in the above circuit. You need to find what is the voltage between these 2 points. That means VAB, voltage between VAB. So that what we need to do, we have to travel in this way to this point. So we will get what is VAB. See, what you need to know for to get the VAB value. This is a dependent source 9I1. This is a voltage source that depends on current, right? So that current that is not mentioned. This is I1. See, this 9I1 voltage source, current dependent voltage source, depend on this branch current. And you see there is a current source. This is a voltage dependent current source. 1 by 6 is the value, and this V1, that is nothing but the voltage between these 2 points. See, this is a little bit complicated problem. Anyhow, we try to solve this problem. So now you see, you can apply any method to find the values of I1 and V1. We need to find what is I1 and what is V1, so that we can go from the ultimate aim is to get what is VAB, right? So what is VAB? VAB means we have to start from this point to go here. So we will write that now. See, what is VAB? You need to travel from B to A, right? From B to A. From B, I am traveling in this way. So I am going opposite to this. So if I am going opposite to this, I need to know what is the value of this V1 by 6, right? So that we need to find that, or otherwise what we can do. You see, this is V1. They have given you this is V1, right? Voltage, that is, this is V1. So from this point, if you travel from minus to plus, you are traveling, right? So we need to reach this point. So from minus to plus we are traveling. So this will be plus V1, and you see I am traveling from plus to minus in this voltage source. What we can write? So this is minus 9 into I1. Right? I have reached point A. So this is expression number 1. So what is the ultimate aim that we have written as a equation? So in this equation, you see, we need to find what is V1 as well as we need to find what is I1. So that is our ultimate aim. See, I will tell you, see this point, this is the node, right? We can say this is a node because 3 branches are connecting at this point. So what I am doing, I am going to take this as node A, this point, node A. What I am going to do, I am going to apply KCL. I am going to apply KCL, right? We can apply, right? We can apply the KCL. And what is this? What is this actually? V1 by 6 is what? V1 by 6, which is nothing but this is the resistor, which means 1 by 6 ohms is the resistor. here, right? But this is given as V1 by 6, right? See, resistor value is 6 ohms, they have given 6 ohms, and the current through this branch is also given as V1 by 6. That we have already know because this is V, and what is the current? Current value will be V1 by 6. That we know that, we already studied these kind of things, right? So we know the current, right? So what I am going to do, you see, I am going to apply, KCL at node A. So you see, if I apply KCL at node A, what is this current? I1 is coming in, this V1 by 6 is going away, and also this V1 by 6 is going away. See, if you see any, this is not a node. Try to understand. I have told you already. If you mark this as a node, you see between these two nodes there is no elements connected. So what I have told you already, if a circuit is given like this, then you have to consider these two nodes as a single node. That I have already told you. See, I1 is coming in, V1 by 6 is going away, and also V1 by 6 is going away. So what we can do, we can put equal to symbol, and I1 is actually coming in, I1 is actually coming in, V1 by 6, another V1 by 6 is going away. So this is V1 by 6 plus this is V1 by 6, right? This is one expression. So what we can do here, we can take the LCM. So I1 will be equal to 2V1 by 6, right? So this can be 3 times, this can be 1 time. And what is the final answer we will get? Final answer, uh, I1 will be equal to V1 by 3. So I am marking this equation number 2. See, we have written the combination of I1 and V1 now. So what I am going to do now, I am going to apply KCL for this loop, outer loop, not for this one. See, I will start from this point. You see, you can apply KCL for any closed loop, See, I will start from this point and I will come like this, and I will come like this, and then I will end here, right? Like that I can apply the KCL, right? So you see, I will apply KCL. See, I will write the point so that you can easily understand. This is A, not A, because I have already written A, B, C, D, A, not A, E, E. We will take it as E, right? So I will apply KCL at B, C, D, E loop, right? For that loop. So I will start from this point now. So I will travel like this. So what I will, the current direction I have to travel in this way, right? So this way. So you see, I will travel from minus to plus in this loop. So what I will get? I will get plus 2 volt, plus 2, and I am traveling in this way. See, this current direction is same as my travel direction. So what I have to do? I have to put minus 3 into I1. That is the voltage value, right? In KCL you have to write voltage, right? That we know already. So I will come like this. You see, in this branch, what is the voltage they have given you already? That is V1. That is given in the question itself. So I will travel from plus to minus in this voltage. So what I will get? Minus V1 minus, because I will travel from plus to minus. That's all. There is no any other element present in this loop. So that should be equal to 0. You see, this is also one of the expression, right? So I will mark this expression as 3. This is already 2. Right? This is already 2, right? Now what you can do, you just substitute this I1 in this expression. That means substitute 2 in 3, what you will get? So I am just substituting, right? So this is 2 minus 3 into V1 by 3, That is, I have substituted instead of this I1, I have substituted V1 by 3 minus, already there is V. So that should be equal to 0. Now you see, all these values are V, right? So what we can do? 2 minus 3V1 by 3 minus V1, that should be equal to 3, 0. So what we can do? 3V1 by 3, that means 3 can be cancelled out. I'm just bringing these two terms to other side. So plus V1 will be equal to 2. So this is 2V1 is equal to 2. So 2 will be cancelled out. So what is V1? Finally, V1 will be equal to 1 volt. V1 will be equal to 1 volt. So you see, we have found what is V1. So we can substitute this V1. I will write substitute V1 in expression number 2. In expression number 2. So what I can get now? So I1 will be equal to, what is V1? That is 1 divided by 3. That's all. That's all right. I have got the value. I have got. What is I1? I1 is equal to what? I1 is equal to 1 by 3 amperes. That is one value. So we have found what is I1 as well as what is V1. So if you know both these values, what we can do, you can substitute here. It is very simple now. It is very simple. So you see, I will write here. So VAB will be equal to, I will just bring this to that side. So VAB will be equal to what? Plus V1. So you just write here, substitute V1 and I1 in expression number 1, right? So VAB is equal to, what is V1? That is 1 volt minus 9. What is I1? What is I1? 1 by 3. So this is 1 times and this is 3 times. So what you will get? VAB will be equal to 1 minus 3. So what at last you will get? So VAB will be equal to minus 2 volt. Minus 2 volt. See that is the question asked, right? So what is the voltage between V and VAB? That is the question asked to find, right? So we have found. So I will summarize this now so that you will get an idea, because this is very complicated. We have applied KCL and KVL at the same problem. In the same problem, we have applied both KCL and KVL for our convenience. So from here, we will solve problems like this. See, till now, we have applied KCL to a problem or KVL to a problem. But now, we have taken voltage dependent, that means dependent sources, and we have applied KCL, KVL in the same problem. This is very interesting. See, if you know basics in electric circuits, then you can apply wherever, if you are very clear in the knowledge of approaching the circuit using KCL and KVL, you can apply it in any circuit. See what we have done here. We have taken a problem. We are asked to find what is the VAB, right? So we have applied KCL at point A and we have derived an expression, and we have applied KCL at this loop, BCDE loop, and we have got another expression. With applying 2 and 3 equation, we have found what is V1 and what is I1. And this equation, that means VAB, that we have already written, we have substituted what is V1 and what is I1 in this expression to get the VAB value. You go through this problem, we will solve another problem in the next lecture, right? Thank you. If you have any doubts, please ask in the comment box. Thank you.